Welcome to an exciting journey into the world of graph databases. Today we're exploring the connection masters of the NoSQL world. Let's start with our first question. What is a graph database in NoSQL? A graph database stores data as interconnected nodes and relationships, perfect for representing complex connections between entities. Think of it like Facebook. People are nodes. Friendships are edges connecting them. Now our second question. Explain nodes and edges in graph databases. Nodes represent entities, people, places, things, while edges represent relationships between them with properties and directions. Imagine a neighborhood. Houses are nodes, roads connecting them are edges. Now, let's explore where these amazing databases shine in the real world. Our first question, common applications of graph databases. Perfect for social networks, recommendation engines, fraud detection, knowledge graphs, and network analysis where relationships matter most. Like Amazon recommendations, people who bought X also bought Y, pure relationship magic. Second question, how does Neo4j differ from other NoSQL? Neo4j is specifically designed for graph operations with native graph storage, ACID compliance, and Cypher Query Language for intuitive relationship queries. While others are general vehicles, Neo4j is a Formula One car built for relationship racing. Time to discover the beautiful language that makes graph queries feel like art. What is the Cypher Query Language? Cypher is Neo4j's declarative query language that uses ASCII art patterns to represent graph structures, making queries intuitive and readable. It's like drawing your query. Person-friends with -friend looks exactly like the relationship. Now, let's look at our Cypher examples section. These examples show how natural and visual Cypher queries can be. They literally look like the relationships they're searching for. Welcome to the revolutionary world of flexible data modeling. First question, NoSQL versus relational modeling. NoSQL focuses on flexible schemas, denormalization, and application-driven design rather than rigid table structures. SQL is like a library with strict catalog system. NoSQL is like a flexible workspace where you organize as needed. Second question, denormalization benefits. Storing related data together reduces joins, improves read performance, and simplifies queries at the cost of some data duplication. Third question, schemaless databases. Documents can have different structures within the same collection, providing flexibility for evolving data requirements. Like a wardrobe where each outfit can have different pieces, no uniform required. Fourth question, MongoDB one-to-many. Model using embedded arrays for small sets or references for large datasets, depending on query patterns and growth expectations. Let's explore how to build beautiful data structures that grow like trees. Modeling hierarchical data in document store. Use nested documents, arrays of references, or path-based approaches depending on depth, query patterns, and update frequency. Like a company org chart, you can store the whole tree in one document or link departments separately. Now, let's examine our nested approach example. This shows how naturally hierarchical data fits into document databases. Second question, what are embedded documents? Documents stored inside other documents, creating rich, nested data structures that can be queried and updated atomically. Like Russian nesting dolls, smaller boxes inside bigger boxes, all part of one item. This is one of the most important decisions in document database design. When to reference versus embed in MongoDB. Embed for small, stable, frequently accessed together data. Reference for large, independent, frequently changing, or many-to-many relationships. Address embedded in person record because they're always together, but person references multiple books because they're independent items. Let's look at our comparison examples. These examples perfectly show when to choose each approach. Embed when data belongs together, reference when it stands alone. IME to master the art of finding exactly what you need in vast databases. How to query data in MongoDB. Use find with query documents, projection, sorting, and limiting. MongoDB uses JSON-like syntax for intuitive querying, like giving a detective specific clues to find exactly what you're looking for. Now, let's examine our querying examples. See how MongoDB queries read almost like natural language. They tell a story of what you're looking for. Second question, MongoDB index types. Single field, compound, multi-key, text, geospatial, and hashed indexes optimize different query patterns and data types. Let's unlock the secrets of database performance optimization. First question, secondary indexes. Additional indexes beyond the primary key that speed up queries on specific fields but require extra storage and maintenance. Like book indexes, find topics instantly without reading every page. Second question, query optimization. Use Explain to analyze query performance, create appropriate indexes, and structure queries to leverage existing indexes efficiently. Third question, compound index. Multi-field indexes that support queries on any prefix of the indexed fields, perfect for complex query patterns. Like a filing system sorted by last name, then first name, works for both. Fourth question, aggregation pipeline. Multi-stage data processing pipeline for complex transformations, grouping, and calculations, like SQL's group by on steroids. Welcome to the most powerful feature of MongoDB, the aggregation pipeline. MongoDB aggregation pipeline in action. Process data through multiple stages like match, group, sort, and project to create powerful analytics and transformations. Like a factory assembly line, raw materials go in, finished products come out through multiple processing stations. Let's examine our aggregation example. This pipeline shows the beautiful step-by-step transformation of data. Each stage builds on the previous one. Now, we enter the realm of building systems that can grow without limits. How NoSQL scales horizontally. Add more servers instead of upgrading existing ones. Data and load are distributed across multiple machines, working together as one system. Instead of making one giant pizza, make many regular pizzas and serve them from multiple ovens. What is sharding? Splitting large datasets across multiple database servers based on a shard key, allowing parallel processing and storage distribution. Like distributing encyclopedia volumes across different libraries, each library has part of the complete knowledge. Now, let's look at our shard key example. This shows how data gets intelligently distributed across servers for maximum performance. Let's master the twin pillars of data distribution and safety. What is partitioning and how it works? Dividing data into smaller, manageable chunks based on rules like range, hash, or list partitioning for better performance and management. Like organizing a massive filing cabinet into separate drawers by alphabet, easier to find and manage. What is replication in NoSQL? Creating multiple copies of data across different servers for fault tolerance, read scalability, and data durability. Like having photocopies of important documents in different safe locations. If one is lost, others remain. Let's examine our MongoDB replica set example. This diagram shows how MongoDB keeps your data safe with automatic backup and failover. Our final stop explores the champions of always available data systems. First question, Cassandra replication. Uses configurable replication factor across multiple data centers with eventual consistency and tunable consistency levels. Like having backup offices in different cities. If one goes down, others keep working. Second question, MongoDB high availability. Replica sets with automatic failover, read preferences, and write concerns ensure data durability and service continuity. Third question, write concerns. Control how many replica set members must acknowledge a write before it's considered successful. Balance speed versus safety. Like requiring multiple signatures on important documents. Fourth question, read preferences. Choose where to read data from, primary for consistency, secondaries for performance, or nearest for speed. Congratulations! You've just completed an amazing journey through the world of NoSQL databases. You're now equipped with the knowledge to tackle any NoSQL interview question with confidence.